Hey guys, we're gonna start nuclear chemistry, but the first thing we need to do is actually review some Chem 1. So it was probably first quarter of Chem 1 when we talked about the atom and the parts, and we'll be doing that a lot this time. So quick review of everything from before. We have our proton that's located in the nucleus. Neutron, same position. And the electron, we'll remember, was outside. Charge of a proton, positive. Neutron, neutral. And an electron, negative. So when it came to mass, different ways we can measure mass. And one way was kilograms, and I don't ever remember that. But a proton, grams, is 1.673 times 10 to the negative 24th. So neutron's pretty close to the same. Electron, much smaller. So instead of doing grams, if you'll remember, we actually came up with a new unit. So instead of grams, we had a unit called AMUs, and that's atomic mass units. So a made-up unit, it's based off of carbon 12. And by definition, if defined off carbon 12, we have a weight for a proton, neutron, and electron. We have always rounded them to say that a proton weighs 1. It's not exact. I've got the exact number here. It is 1.0073. So close, so we just rounded it to 1. We also said that a neutron had a weight of 1. Again, it's not an exact number. The more exact was 1.0087 AMUs, but we just rounded it to 1. And if you'll remember, we let an electron have a weight of 0. Well, it wasn't really 0, it was 0.0006 AMU units. So this was what we were talking about in terms of weight of our atoms. So again, when we're thinking about stuff, I've got the atomic number, which is always equal to the number of protons. It also identifies the element. So if I know the atomic number, I also know the symbol, because carbon, for instance, has an atomic number of 6. You're never going to have a carbon with an atomic number of 5 or 7 or any other number. So the atomic number is always equal to the number of protons. And if you'll think back to your periodic table, and have included one in your packet, the atomic number is the whole number. It's the sequence of the periodic table. So here's 6 at the top. There's carbon. So we identify our elements based on their atomic number. Then we have isotopes, and we mentioned briefly isotopes, and then we didn't really do much with them at all. Isotopes are variations of an element. So it's an element, the same element, but with different numbers of neutrons. So atoms of the same element with different number of neutrons. Okay, so what we learned before was that there's absolutely no difference in an atom with, say, 5 neutrons or 6 neutrons. It's just a variation. It changes the weight of them. Not exactly true, and that's where our whole nuclear chemistry stuff comes up. What you're going to see then is different ways that we write isotopes. So for instance, we can write an isotope of hydrogen as hydrogen 1. And sometimes that's not really a minus sign. Sometimes we see a little dash there. So this is the most abundant isotope of hydrogen, but there's other forms of naturally occurring hydrogen. So another one might be hydrogen 2. Hydrogen 1, this number represents the total mass. Hydrogen 2, this number again represents the total mass. Think back. Our mass is only our protons and our neutrons added together because we essentially said that electrons have no weight. Another way that we can notate this, and what we will use a lot in our nuclear equations, is we write it in a different form. We put the symbol, and then we come to the left side. So on the left bottom, we write the atomic number. So we find hydrogen, periodic table, find the atomic number, has the atomic number of 1. So it goes on the bottom left. On the top left, we put the total weight. So the sum of the protons and the neutrons. And in this case, that is this number. So the protons and neutrons for this substance, when added together, are 1. So this hydrogen 1 has to have 1 proton. I know that because it's hydrogen and doesn't have 1 proton, it's not going to be hydrogen. And there could be no neutrons simply because that's what it weighs. It weighs 1, and we've already got that. Oftentimes we ignore electrons in these, but if something gained or lost electrons, we could put the positive or negative number over here to show that it gained or lost electrons. So hydrogen 2, again, symbol H. From its periodic table, its atomic number, we know that it has to have an atomic number of 1. And now we're looking at the total weight. Well, the total weight of this substance is 2. So that goes here. So the mass of it, the mass number, that's what's here, mass number, mass number. The mass is on top. The number of protons is on bottom. And again, if we wanted to, we could include a charge. So let's do some practice. And you actually have a bit of practice coming up. So carbon 12. Again, I didn't put the dash, but find carbon on your periodic table. Carbon on the periodic table is number 6. So it has to have 6 protons. Now to find the neutrons. Right here, 12. That is the sum of everything that provides its weight. So the protons were each 1, the neutrons were each 1, electrons were 0. So if 6 of this weight come from protons, that leaves 6 to come from the neutrons. And electrons I included on this chart. So we're looking for a charge. And I don't see anything about a charge over there. So if there's no charge, I know that the number of positives and the number of negatives have to be equal. So that would also have 6 electrons. Now carbon comes in another form, and the other form of carbon is carbon 14. Now this is most of the carbon that is out there, but there's some carbon 14. Again, based on its periodic table, it has to be a proton number of 6, neutron number this time. Protons and neutrons together were 14. 6 for protons. That leaves 8 for neutrons. And again, for electrons, I'm looking for a charge. I don't see a charge, so it must be the same. And it is. Same idea here. We've just written them in a different format. So this is that alternative notation. This is the one you're going to use the most. So silicon, I can find it on the periodic table. And okay, when you find it, it's on periodic table. And you probably can't read that, but it says 14. Oh, well, I didn't even have to look it up on the periodic table because if it was written correctly, that should be it. So the number of protons is 14. Neutrons. This is the sum of the protons and the neutrons together. Each proton weighs 1, each neutron weighs 1. So the total number of neutrons, this is kind of nice because it's set up as a subtraction problem already. So if I subtract, I got 21. There are 21 neutrons for the substance. Again, look for a charge. There is not one. So the number of electrons is 14. Same process. Protons. This is the total mass. So do subtraction to get your neutrons. And for this one, there is a charge present. Because I see the positive, I know that the proton number must be larger than the electron number. And this number must be larger by 2 specifically. So protons was 30, neutrons 35, and that left the electrons to be 28. Why did I not change the proton number? If I would have changed the proton number, the symbol would have to be different. So remember, you never change the proton number. If you do, you change the symbol. Same idea here. Uranium, 92. It's set up as a nice subtraction problem. So 146, no charge, 92. And your last problem, you're trying to fill out this formula here. This is our complete formula, and I think that's how it's worded on your practice, is a complete chemical symbol. So we need to first figure out what we're dealing with. So number 19 on the periodic table is potassium. So remember that atomic number goes down at the bottom. The number at the top is the total mass, so the sum of the protons and neutrons. So it's 39. And my protons and electrons are not equal. So I have more protons, which are positive, and I only have them greater by 1, so I can just leave it like this, or I can put the 1 with it either way. So different ways we can write our isotopes. We can write it out, or we can do this complete symbol. And I've just showed you on these one particular isotope. There's possibly lots of variations depending on what the element is. So I've got some practice for you on exactly this stuff. Make the number, tell me the number of protons, neutrons, and electrons, or when given that, tell me the complete chemical symbol. This should be either in your packet as one of the first assignments, or you can find it on the classroom. And it looks really long, but it really doesn't take very long. It's the one that says 3 practice problems. You can just email your answers to me, and that'll be the easiest way to go through it.